Hello everyone, this is 7.2, Modeling with Linear Equations. Recall a couple formulas we talked about last time, the slope formula, which takes in 2 points and spits out just the slope, and the slope-intercept form, which is the form of an equation of a line that gives you the slope m and the y-intercept b. We're going to add one to this called point-slope form, and it is this equation y minus y1 equals m times x minus x1. The catch with this one is that it takes in a point, x1, y1, and a slope, and it gives you the equation of a line. So if you look at these last two equations here, the slope-intercept form and the point-slope form, they're both equations of a line, and luckily they both say exactly what goes in them. The slope-intercept form happens to have a slope, m, and a y-intercept. The point-slope form happens to have a point, x1, y1, and a slope in it. So both of these equations tell you what you need in order to build these equations. So some of these problems will give you some type of information, and you're going to use that information and plug it into whichever version it makes sense to plug it into. Before we move into this new stuff, I want to backtrack real quick to a problem on page 312, number 82. This problem is very much like, I think, the first problem on the Chapter 7 project, so pay attention. This one says Cassandra is comparing two cell phone calling plans, BT&T, which charges $12.75 per month and 7 cents per minute, and Singleton, which charges $14.15 per month and 5 cents per minute. Interpret what the solution to the system tells you. How should Cassandra decide which plan to take? So let's ignore that first question, the interpret the solution thing. How should Cassandra decide which plan to take? Well, essentially what's happening here is you have these two plans. You've got your BT&T and Singleton, and one of them starts, the BT&T, in fact I'll give you a little graph to go along with this. Oops. The BT&T plan starts less expensive, so maybe this is the starting cost somewhere down here. But it's more expensive per minute, so as you use up minutes, the price is going to increase a little bit faster than the other one. So this is a BT&T plan. The second one, Singleton, actually starts out more expensive, so maybe we can plot it somewhere up here. But it costs less per minute, so as your minutes increase, your price still increases, but not as fast. And now you can see what happens, right? Somewhere here in the middle, these two plans are going to be the same price. And if you end up using more minutes than that, you're going to end up spending more money on one plan, or one plan is going to be more expensive, one's going to be cheaper. So let me just show you. The Singleton plan starts out more expensive. So if you use less than whatever this amount of minutes is, Singleton is going to be more expensive and the BT&T will be less expensive. If, though, you use more minutes than this, whatever this number of minutes is, the BT&T is now going to be more expensive, and the Singleton is going to end up being less expensive. So there's kind of this cutoff point, and we need to figure out what that cutoff point is, because when it says, how should Cassandra decide, well, it basically comes down to how many minutes does she think she's going to use. If she thinks she's going to use more minutes than this per month, she should go with the Singleton because it's cheaper in the long run. If she thinks she's going to use less minutes, though, she should go with BT&T because it's going to be cheaper in the short run. So our goal is to find this cutoff point. And the way we're going to do that is we're going to create two equations for both of these, and we're actually going to set the equations equal to each other and solve for the value that makes them the same. Because remember, that's what we're looking for. We're looking for actually the x value, and x here is going to stand for minutes, that makes the cost of these two plans the same. So real quick, let's just note that x, we'll start with y, is going to be the monthly bill. I'll just say monthly cost. Right, that's how much she's actually going to end up paying per month. And x is going to be minutes spent per month. And again, if this part seems confusing to you, don't forget, if you have an option, always let your x be time. And here, the flat rate is the rate per month. That's going to be like our b in the y equals mx plus b. And our m, our slope, our rate of change, will be the cents per minute. So when we plug in an X and you multiply by the cents per minute, that'll tell you how much money you're being charged for just the minutes you use, and then you'll add back on your monthly flat rate. So let me show you how we could build these. So we'll start with our BT&T. If we want an equation that models this, Y is going to be the monthly bill. Oops. BT&T, this one was 7 cents per minute, so this will be 0.07x. That's 7 cents times x, which is the number of minutes, right? And that'll calculate how much you're going to end up paying just for the minutes that you use. But no matter what, each month you have a flat fee. For BT&T, that flat fee was $12.75. So there you go. This is an equation that models the monthly bill for BT&T, Y, given some number of minutes, X. And we'll do the same thing for Singleton. We've got Y equals. This one will be 5 cents per minute. And it has a flat rate of $14.15. Now our goal, again, is to figure out for how many minutes, so that means we're solving for X, will it take until these two plans are the same cost. So remember, Y is the cost, so we want to know when these two things are equal. So we're literally going to say, take these two equations, take this piece, and set them equal to each other. When is the cost, when is the Y value is going to be the same? So we'll just take that first expression up here, the 0.07x plus $12.75. That represents the monthly cost for BT&T, and we want to know when is that monthly cost equal to the monthly cost for Singleton, which is 0.05x plus $14.15. Oops. Right, so we're literally taking these two equations, setting them equal to each other. And now we just have to solve for x. So this just means this is a basic linear equation, even though there's decimals. Calculator can do the hard part for us. We need to get all our x's on one side, all our numbers on the other. So I'm going to move this 0.05 x. I'm going to subtract it from both sides. Cancels out here, and now over here we have 0.02x plus the 1275 equals 1415. So now all our x's are on the left. Similarly, we need to get all our numbers to the right, so I'm going to subtract the 1275 from both sides. Cancels out here, and we're going to get 0.02x equals, and if you subtract these, you can just throw them in the calculator or do the actual arithmetic. We'll get $1.40, $1.40. And lastly, to get x by itself, we're going to divide both sides by 0.02. And we get x equals 70. 70 what? Well, remember we defined x as the number of minutes. So this means 70 minutes. So this is kind of the answer, but it's not really our conclusion, right? Our conclusion is, if you go back to that graph, our conclusion was one of them starts out more expensive. That's our, let me show you, that's our Singleton here, the 1415, right? Starts out more expensive, but has a slower growth rate per month, or sorry, per minute. This one starts out less expensive, but a higher growth rate per minute. So the cutoff is 70 minutes. At exactly 70 minutes, these two plans cost the same. So if Cassandra wants to make a decision, she has to think whether or not she's going to use less than 70 minutes or more than 70 minutes. If she uses less than 70 minutes, she wants to go with the plan that is less expensive from the beginning, which would be BT&T. Right? This one starts out less expensive, and if she uses less than 70 minutes, the price here will actually be less than this one. Now, 70 minutes isn't a lot, depending on whatever you use. That's for 1 month, right? So I think most people would probably say, well, I'm probably going to use maybe more than 70 minutes, so you might want to go with Singleton, which starts out more expensive, but in the long run, if you end up spending, in fact, we know exactly the long run, if you end up spending more than 70 minutes, this is going to be less expensive overall. So the whole point is you're looking for that, that point where they're equal, and then you're making a decision based on, do you think you're going to spend more than that, or sorry, use more than that, or use less than that many minutes. Okay, now this problem here is just a review of some basic algebra stuff again, but it's going to use that new equation that we had, the slope, or sorry, the point slope form. Now notice the problem doesn't say anything about point slope form. It just says write the slope intercept form, which is our y equals mx plus b, of a line with the slope 3 that passes through 2, 1. Well, don't forget, y equals mx plus b, you need two things for this equation. You need an m and a b. We have an m, it's 3, right? Our slope is 3. But we don't have a b. A b is our y-intercept, and we're not given that. We're just given a point. Even though that point has a y-coordinate, right? The y-coordinate is 1. That's not the same as our y-intercept. So we can't go directly to slope-intercept form. But like I said at the beginning, think about what we have. We have a slope, and we have a point. So wouldn't it make sense to use point-slope form? Which is y minus y1 equals m times x minus x1. That's our new equation, and again, it requires a point and a slope. Look at what we have. We have a point and a slope. Let me move this real quick. So in order to use this, we need to use our m and our b. We already said this is our m, the 3. Sorry, not m and our b. Our m and a point. Our point is x1, y1, so I'm going to actually label this point here, x1, y1. So now you can see what we're going to plug into this formula. We're going to have y minus y1, which is 1, equals m, which is 3, that's our slope, times x minus x1, which is 2. Now the good news is this is actually the equation of the line right now. The bad news is it's not in slope-intercept form, and they asked us to write it in slope-intercept form. This is technically in point-slope form. So we have to take this and write this in slope-intercept form now. And I told you in the last video, you can take any equation and write it in slope-intercept form by simply solving for y. So our goal now is just to get y by itself. So there's a couple things we're going to have to do that. We're going to have to take this 3 and distribute it to the x and the 2. And then we're going to have to add this 1 to the other side. That's all we have to do to get y by itself. So let's start with the distribution. Right, 3x and 3 times minus 2. That'll give us a y minus 1 equals 3x minus 6. Right? And now we just need to add this 1 to both sides. We cancel out here and we'll get y equals 3x. Negative 6 and positive 1 give us a minus 5. And there we go. We now have the equation of this line in slope-intercept form. So keep in mind, even if a problem asks you for slope-intercept form, you might not start with it, because in this case we didn't have the pieces we needed. We didn't actually have this minus 5. Right? This is the b that we ended up getting, but it wasn't given to us anywhere in this problem. Right? So start with what you have. We have a slope and a point, so go to point-slope form right here. And then if you have an equation in point-slope form or in any form, you can always get it to y equals mx plus b simply by solving for y. And that's what we did in these steps here. Alright, so we're going to kind of put this all together and try to solve this problem on page 320, number 28. We have direct satellite receiver sales. They decreased from 16.3 million in 2004 to only 12 million in 2009. Model these data by a linear equation and predict the year when the sales will drop to 8 million. Well, we are given 2 points here. It says it decreased from 16.3 million in the year 2004, that's 1 point, to 12 million in 2009. Now we can use these raw points, these raw years, but remember it's sometimes nice to not have to use the raw years, and because these are numbers like 2004 or 2009, we can treat 2004, since that's our first year, like year 0. And then the year 2009, that'll be 5 years after 2004, we'll just call that year 5. Everything should work out the same. We just have to be careful when we predict a year or do a prediction with the year. We're not going to get an actual year, right? We're going to get a number like 10 maybe, and 10 is going to stand for 10 years after 2004, which would be 2014. So let's take these 2 points. Start with the 2004. Remember, time is x, so that's going to be our x coordinate. And instead of 2004, I'm just going to use the point 0. So 0 for year 2004, and then 16.3 million will be the number of sales. That's our first point. And then the second one is 2009, which we said was 5 years after 2004, so it'll be 5, and the sales were 12 million. So there we go, and you can see this is already a little bit nicer than having 2004 with the 16.3 and then 2009 with the 12, because that'll just make our arithmetic a little bit more complicated. So we have 2 points. Now it says model these data by a linear equation and then use it to do a prediction. We need to come up with the equation of a line, and let's go ahead and shoot for y equals mx plus b because it's usually the easiest, or it's actually the best form to have it in. Now we only have 2 points. No matter what, we're going to need a slope, right? And we don't have a slope yet, but we have the slope formula that lets you take 2 points and calculate the slope. So we're going to call this point x1, y1, and this one x2, y2, and we're going to plug this into our slope formula. M equals y2 minus y1 over x2 minus x1. Right, so in this case, our y2 is 12, our y1 is the 16.3, our x2 is 5, and our x1 is 0. So when you crunch these numbers, you get about negative 4.3 over 5. This is okay. You could also turn this into a decimal or something. Since it's kind of like a fraction, let's go ahead and just keep it a fraction. The only problem is we don't really like to have decimals inside our fraction. So since we have negative 4.3, if we multiply that by 10, remember multiplying a number by 10 just moves the decimal over once to the right. So that's just going to give us a negative 43. Right? Because you're just multiplying by 10, moving that decimal once to the right, you get a negative 43. So that's a nice whole number. The catch is you can't just multiply 1 by 10. You have to do the same thing to top and bottom in order to keep it the same number. So we're actually going to call this slope here negative 43 over 50. All right, so that just makes it a nice fraction. Okay, so now we have a slope, that's our m, and we have 2 points. Well, what we're going to do, or what we could do, is go to our point-slope form, right? We have a slope, we have a point. In fact, we have 2 points to choose from. We could use point-slope form and get our answer. Now, we could cheat actually a little bit as well, because remember, since we set this this year as year 0, this is automatically our b, because remember, b, your y-intercept, if you're on the y-axis, that means x is 0. Since we know x is 0 here, this is the point that goes with it. That means this is going to be our starting value. This is going to be our b. So we automatically know that that is our b. Now, this wouldn't have happened if we used the actual year 2004 and the actual year 2009. Right? If we use those years, that wouldn't be our b. We'd have to do a little bit more work to get it, and then we'd have to go to the point slope form. Okay, so in this case, though, automatically we know our b, and I'll just make a note of that here, b equals 16.3. And that's good news, because look what we have. We have a slope, negative 43 over 50. We have a y-intercept b, which is 16.3, and that means we have an equation, y equals, I'll go ahead and just write the form real quick. Y equals mx plus b is what we want. We have y equals negative 43 over 50x, right, that's our m, plus b, which is 16.3. So there's the first part of this problem. We have our linear equation that models the data, and it's in y equals mx plus b. So that's the first part. Now what we're going to do is we want to predict the year when sales will drop to 8 million. Let me get back to our equation real quick. Okay, predict the year when sales drop to 8 million. You have to keep in mind what your variables stand for to answer questions like this. X is the number of years after the year 2004, in fact, right? And Y is going to stand for the number of sales in millions. So when they ask us predict the year, they're clearly asking us for an X value. And it's very important that you identify that before you start doing the second part of the problem. They're asking us for an X value, and if you want an X value, they better have given you a Y value. Well, they did, right? They said predict the year when the sales were 8 million. why are your sales in millions? So all we have to do for this problem is plug in 8 for y and solve for the x that goes with it. So let's do that. We're going to plug in 8 for y. And then we're going to solve this equation for x. So if you solve this equation for x, there's a couple things you have to do. The first thing is you're going to have to subtract 16.3 from both sides. You're going to move it to the other side. They cancel out here, and over here you're going to get a negative 8.3 equals negative 43 over 50x. Okay, and then the next thing is we want to get x by itself, so we're going to divide both sides by this number, negative 43 over 50. It looks complicated, but remember, you can just throw this in the calculator to get an answer out of it. And I recommend that. I know this is the beginning of the semester, but I want you to realize we're going to use the calculator a lot in this class, and that's okay. In theory, you should know how to do this arithmetic by hand, but in practice, you will never have to. For the final exam, for any exams you take, any work you do, you should have the graphing calculator right next to you, because this class is more about exploring different fields of math rather than arithmetic. So don't be afraid to use the calculator. Okay, so if you plug this into the calculator, you should get a number like, it's going to be a long decimal, so we'll round it to about 2 places or so, 9.65. Okay, now let's think about what we were solving for. We were solving for the year in which the sales will be about 8 million. We just got 9.65, so are we going to say the year 9.65 or the year 9 or the year 10? Well, keep in mind what our x stands for in this equation. Since we didn't use the year 2004, we used it as year 0. X is the number of years after 2004. So if you take this number and add it on to 2004, let me just divide this real quick, 2004 plus the 9.65, you get something like 2013.65. Right, so what year will the sales reach 8 million? In the year 2013, a little bit over halfway, right? So 2013 would be our answer here. And that's it. Let me know if you have any questions. Hope this helps.